Yes, hello. Am I audible?
Yes, ma'am.
Yes, ma'am.
Aisha, Aram, and Fatima. So, Aram, what happened? Last class you missed? See, let me just give you a brief of what we had started.
Ma'am, I watched the video.
You've seen it? All
Yeah.
right, very good, fine. So, Fatima, it's your first lecture of motion under gravity, basically motion in a straight line. So, see, Fatima, the rest of the backup things we'll discuss later, but for right now, do one thing. Just take the screenshot of these.
Okay, ma'am.
Just take the screenshot while I'm just telling you. See, acceleration due to gravity is fixed. The value of acceleration due to gravity remains fixed. Now, the terms like displacement, velocity, acceleration, all these. Have you heard of these terms? Are you aware of these terms? Velocity, acceleration.
Yes, ma'am.
You are aware. So, acceleration is basically rate of change of velocity. Now, some acceleration are uniform, some accelerations are non-uniform. So over there, Aisha, can you explain what is meant by uniform acceleration? Just the term uniform acceleration. If you wish, you can even type it. Uniform acceleration.
Velocity changes in regular intervals of time.
Velocity changes in regular intervals of time. Fine. Velocity changes in regular intervals of time. That's right. So, see, acceleration can be uniform, it can be non-uniform. If the acceleration is changing, then we call it as non-uniform acceleration. If acceleration's value remains fixed, then we say it is uniform acceleration. Now, acceleration due to gravity's value is fixed. Why am I so emphasizing on this? Because in today's class and in this topic, motion in straight line, this will continuously be used. So that's why for the continuous usage of this, you should be aware of what we write as it as 9.8 meter per second square. And we round it off to 10 meter per second square. Now, from this, the other important things, yes. See, you have to remember the direction of acceleration due to gravity, all of you. It's downwards. In any ways, in any manner, it's downwards. Acceleration due to gravity will act downwards. Now, regarding the directions and the sign conventions that we choose is that you choose either upwards or downwards as positive or negative by your choice. Let's say Aram has chosen upwards direction as positive. So for her, acceleration due to gravity, which is acting downwards, will be minus, and all the forces and the velocities and the rest of the things that are acting upwards will be positive for her. Let's say Maha has chosen opposite, downwards is positive. So for Maha, acceleration due to gravity, which is always directed downwards, that will still be positive. But for Maha, now everything that is pointing upwards, like velocity or anything, whichever is the case, that will be negative. So it's up to you, basically, however you choose it. It might be difficult to understand some of the terms, so no worries, we'll be having a class. So not only with you, Fatima, with you also, Maha, from which lecture did you join? Do you remember which class you started with?
No, ma'am, I don't remember.
I think basic terms like velocity, acceleration, displacement, and everything was covered.
Yes, ma'am.
So I'll be having a class with Fatima and you as well. So, okay, one thing that was left in the last class which we were having was that. So this is clear. What we'll choose. Oh, this thing will get clear with the help of question also. So don't worry about it. Regarding one more thing is very important. See, this is ground. Let's say this is ground. Now I have thrown a ball upwards. I have thrown this ball upwards. Now, if I throw this ball upwards, obviously it will come downwards. because of force of gravity, because of the attractive pull of the earth. Obviously, if you throw anything upwards, it will come downwards. So what happens is that some things you should remember, because these are important from your numerical point of view. Nobody is going to ask you these things to write it in the exam. Basically, in the numericals, it gets involved, and then you have difficulties in solving the numericals. So see, from the ground, I have thrown a ball upwards. It will move, it will move, it will go, it will go. It will reach a point. Let's say the initial velocity of this ball was 5 meter per second. I had thrown this ball with 5 meter per second velocity. What happens gradually as the ball goes up or higher, or any object goes higher? As the height increases, velocity decreases. So ultimately, let's say at this point, it may happen that the velocity becomes 3 meter per second, and ultimately at this highest point, this is the highest point, the velocity, final velocity becomes 0. Remember, at the highest point in motion under gravity, that is motion in one line, in straight line, at highest point your velocity becomes 0. Now, what will happen when velocity will become 0? It will not be able to move further. That's the point where you can identify that its velocity has become 0. Even if I throw this pen, obviously in the screen it will not be able to show completely, but there was a certain point for a very small fraction where it came back to my hands. So that showed that the velocity, the pen's velocity, initially it was going, velocity decreased, it became 0. No velocity was left, no momentum was left to throw it further. It came down. This is first point that you have to remember regarding this initial velocity. This upward moment is known as ascent. So we call the time duration from throwing it from the ground to the highest point, we call it as time of ascent. Time of ascent. Now, what will happen to the ball? Now, its velocity is what? Its velocity is 0 right now. It is falling down now. So it's falling, and it has to reach the ground back from where it has started. So there will be a point where from 0, the ball has again gained that same velocity, 3 meter per second, and it will be at the same exact position which occurred when we were throwing the ball upwards. And similarly, ball will move, and ball will reach with the same velocity with which we throw, provided the frictional forces, resistive forces do not occur and do not change it. Obviously, we have not discussed friction because it comes in your laws of motion, and we'll be discussing it. You have full-fledged chapters in numericals and formulas on friction, so that we'll see in detail. But right now, friction you people are aware of from your lower classes, that whenever motion occurs, a resistive opposing force is known as a frictional force. So because of the air friction, air drag is there, and many factors, it can happen that the velocity will be slightly different, but more or less this is the case. Now this downward motion, this is known as descent. These are normal English terms. You will be able to identify. Descent means something that is moving downwards. Ascent, something that is moving upwards. So this is known as time of descent. Now, how will it help you in numericals? In numericals, remember that time of ascent is equal to time of descent. So if somehow you have calculated the time for the ball to move up or for any object to reach the highest point, that same amount of time will be required to move it downwards. And second point is that at highest point, velocity becomes 0. That's the reason why anything falls. Okay, just note it down, then we'll start with the numerical portion. do one thing. First, note down the question and just try to make a rough figure of what exactly is happening. So then we'll discuss it. In 2 minutes, we'll discuss it. No need to solve everything. It's okay. I'll solve it for you, the first question. But at least just try to make a rough figure of what exactly is happening on what and what is the question asking you to calculate. So I think you must have written it by now, and at least you must have seen an idea of what the question is asking. Now, a ball is thrown vertically upwards with a speed of 19.6 meter per second. So, Aram, can you tell me one thing? Are we throwing it from the ground, the ball? Aram,
Sorry, ma'am?
are we throwing the ball from the ground level?
Yes. No, from the tower.
Top of the tower. See, it means we cannot consider the examples that I was telling you previously. Those are not applied here. From the ground, the ball has not been thrown up. It's the top of a tower. It's like, let's say this is a top of a tower. See, focus on this. Let's say this is a tower. The height of this tower is AB. This is AB and the height is H, which we do not know. That we have to find out. A ball is thrown from here. It's like you go, it's like one of you, like let's say Fatima. Fatima has thrown the ball from the ground level. Aisha, she went upstairs, she went to the rooftop, and then she threw the ball. That's the difference. So here also, let's say some mass of ball is there and the ball is thrown with a speed of 19.6 meter per second. So obviously it will cover its path and it will return back. Now, it's don't consider it as a projectile motion. It is similar in one dimension motion. Motion in 1D is only occurring. It's just I've drawn this line separate so that you know this is ascent time, this is descent time. Fine, let's take a point, highest point. Let's say this is the highest point. All right. Let me take it as the highest point, H. Now, A, H, B. This is the whole journey of the path covered. So let's take one direction as positive and let's take the direction as negative. That's what I've told you earlier. You have to mention what's your sign convention because both the conventions are correct, whatever you choose. Let's say, let me choose upwards as positive and downwards as negative. Upwards is positive and downwards as negative. I have chosen. You wish, you can choose everything, anything, whatever you wish to choose. Now I have chosen, and again reminding all of you that you have to mention specifically of the places of the sign conventions wherever it is used in every place. You have to mention that you have taken upwards as positive because sign convention is not standardized. It's different for different person and different answer sheets. So in your paper, in your exams, you have to specify that you have taken it as positive, upwards, negative, right, left, whatever. So right now, as I've mentioned, upwards is positive. So whatever, now I can solve the paper in my wish. So velocity. Fatima, can you try? Velocity will be up, positive or negative?
Positive.
Positive. Yes, right. See, ball is moving upwards. So velocity of the ball will also be upwards. That's why the ball is moving upwards. No, if I apply the velocity like this in the downwards direction, do I expect the pen to move up? No, because the velocity has been applied in the downwards direction. Similarly, here the ball has been thrown up, so velocity is also upwards. So since velocity is upwards, we'll write the initial velocity as plus 19.6 meter per second. Fine. Aisha, tell me about acceleration due to gravity. What should I write over here?
9.8
That's fine. 9.8 plus or minus? Minus. Yes, definitely minus because acceleration due to gravity always acts in the downwards direction no matter what. That's why it's pulling the objects. So acceleration due to gravity, it will be minus 9.8 meter per second square. We can round off it to 10 also, but here I think nothing is mentioned. So let's take it as 9.8 meter per second only. And obviously it's given 19.6. I think we'll be able to solve it. Now, distance, basically separation is what? We have to find out the distance. See, the displacement that has occurred. Displacement, if the body has started from A, it went to H, means AH has been covered. Then it went downwards to this point again, HA back. And then again, this additional distance it covered, A. Can anyone tell me out of all these values, what is the displacement? This is the whole distance that I've written. AH plus HA plus AB. This is the whole distance. What is the displacement in this? Anyone?
AB.
AB. Perfect. It will be AB. See, for all those who are not aware of, displacement is basically the shortest path covered and it's the separation between initial and final positions. So the separation between initial and final positions, we call it as displacement. So here also displacement, initial position was A, final position is B. So it's basically AB. So my distance is basically AB, which I have to find out. Why? Because it's the height of tower. That's the height of tower. So displacement will be what? Displacement will be how much? It's H. And obviously the body is coming downwards. Displacement is coming in downwards direction and I have chosen downwards as negative. So I'll write it as minus H. Time can never be negative, so obviously time will always be plus 6 seconds. I have all the values with me. Can I use the equation? Motions of equation we have done, uniformly accelerated motion. Maha, were you there in those classes when we did the equations, the 3 equations?
Yes, ma'am.
Okay, I think from there you've started. So Fatima, you have missed it. Fatima, are you aware of the equations of motions, the uniformly accelerated equations of motions, v is equal to u plus at and all?
No.
You're not aware of. Fine, Fatima. So till the time we are not having the complete backup class, by that time, just learn this equation, that there's an equation which connects initial velocity, acceleration, displacement, and time. We'll today only discuss the timings about the backup classes. So the equation is ut plus half at squared, where s is the displacement, u is the initial velocity, A is the acceleration, and T is the time. Or rest of the equations we'll keep on doing as it will come on our way, because in this we have to use these equations. So displacement is minus h, initial velocity is plus 19.6 multiplied by time. Time is 6 plus half. Acceleration is acceleration due to gravity. That's basically plus minus 9.8 into square of time, that is 6 square. I've just kept everything in the formula with the help of sign conventions. Just understand this question in detail. We'll do more questions. We'll do in today's class only. We'll do questions on free fall. We call this as free fall. I'll tell you that also. So what's there? Minus, this is 117.36, no, so 6. 117.6, and this becomes what? 36 is there. 6 into 6 is 36 into 9.8. So this becomes minus 176.24. That's become 4. I think this is it. Just check, anyone. One of you just check, see the calculation. So minus h. So it's 117.6 minus 176.4. 14, 6, that becomes 8.8 and 5. So minus 58.8. Negative sign gets cancelled. Height becomes 58.8 meters. That's the height of the tower that we wanted to calculate and find out. See, I'm just repeating the steps, then you can note it down comfortably. We just wanted an equation to connect all of these. First, we wrote all the variables, chosen the sign conventions, and we wrote all the variables. Once after writing the variables, we have just substituted the values with along their sign convention. And then normal mathematics to find the height of tower. We'll do more questions, it will get clear. If you have any doubts, ask me. Otherwise, start noting from here. Now see, in this question, this is a very similar question to the previous one that we have done. Anyone got the answer of this? The velocity is given to you. This time height is given to you. Time is missing. In the last question, what happened? T is equal to 6 seconds was mentioned to you. Height of the tower was unknown. This time T is equal to 6, not 6 seconds, whatever time comes, that is missing, but height of the tower is given to you. So again, a ball is thrown vertically upwards with velocity 20 meters per second from the top of the tower. So the story is the same. Like if we say this is some tower A, B, the height is there 25 meters. The ball is thrown upwards, and then obviously it will reach the highest point and the ball will come back to the ground. Any doubts from the previous question? If you are having any doubts in any portion or any step, ask me, because these are the basic questions. Questions will be modified. Now, again, so velocity, initial velocity. Who is good? Maha, can you try? What should be the velocity? Just 1 second. Let me take the same convention. Let me take upwards as positive and downwards as negative. Yes, Maha, try. Yes, Maha.
Plus 20.
Plus 20. Perfect. As ball is moving upwards, this will be plus 20 meter per second. Fine. Air up. Acceleration due to gravity.
Minus 9.8.
Minus 9.8. And in this question, I've forgotten to write one thing. This is actually a question from your NCRT. So this is a very important question. Here in the question, it was mentioned to take G as 10 meter per second square. So we'll take it not as 9.8, we'll directly take it as minus 10 meter per second square. Aisha, can you tell me the height?
Height of the tower.
Not height, basically the displacement. What should I write as the displacement? See, it will 25 will be the magnitude because it is going from A to B. So obviously 25 meters will be covered. As we saw in the last class, whatever was the displacement that came out to be the height, not the last class, the last question. Will it be minus 25 or plus 25? Aisha.
Minus
Minus 25. See, ball is ultimately going downwards. The displacement that has occurred is in downwards position. Your initial position was A. Your final position is B. Are you moving downwards or upwards? For reaching the point B, you are moving downwards. So here you will write it as what? You will write it as minus 25. Now we have to find out the time. So we'll use this equation ut plus half at square. Let's put everything. U is, so displacement is minus 25. U is 20 into t we are not aware of. This is what? Half into 9 into 10 into 10. This is half into 10. Not 90, half into 10. Basically, that's the acceleration due to gravity. Into t square. All right. So what are we left with? If you see this, okay, not 10, minus 10, minus 10. Acceleration due to gravity is pointing downwards. See, if we see this equation, we are left with minus 25 is equal to 20t minus 5t square. This gets cancelled. Now, let's even take 5 common. If we take 5 common, this becomes minus 5 is equal to 4t minus t square. So let's transfer everything. For the solving of equation, let's transfer. This becomes t square. This becomes minus 40 and this was already minus 5 is equal to 0. So using your splitting the middle term concept and any concept, your quadratic equation concept, you have to solve and find the value of t. Let's do it. So this will be equal to t square. So 5 and 4. So plus 5 minus 5 plus 4. So this becomes minus 5t plus t minus 5 is equal to 0. We have just splitted this middle term, this term. So this t is common, t minus 5. From here plus 1, then t minus 5 is equal to 0. So we have two equations. T plus 1 and t minus 5 is equal to 0. From here we can say t is equal to minus 1. From here we can say t is equal to 5. Fatima, which one of the time value should I choose among these?
5.
5. T is equal to 5 seconds. Because time cannot be negative. So this is your answer. Noted. Try this question, all of you. Whoever gets the answer, submit me in the chat box. After the class, do practice these questions well because we are almost towards the end of the lesson. After this, only relative velocity is left. Yes, Aram. Good. Right answer. So Aram has submitted the answer already. Others also try. And we'll do few graphs as well. Then we'll be able to end this lesson. Yes, yes, Ma. Right answer. Maha, whenever you're mentioning the answer, no, to mention the units alone. Okay. So two students were able to solve it, Maha and Aram. See, the question says what? Question is simple. You'll be able to do. It's a one-liner answer. When it says take G as 10 meter per second square, your answer is. It says a food packet is released from the helicopter, which is rising steadily at 2 meter per second. Now, after 2 seconds, what is the velocity of the packet? So, if a helicopter is moving, it's rising steadily, and you have dropped a packet. A food packet has been dropped from it. So, Let's say a helicopter is moving, food packet has been taken. Helicopter is rising, but food packet has been thrown down. Helicopter is rising, food packet has been thrown down. When the food packet was thrown, can any one of you tell me what would have been the initial velocity of the food packet? Is it 0 or is it some value?
2 meter per second.
Yes, Aisha. Perfect. See, it says it's a helicopter present. It is rising steadily with 2 meter per second. Even if you also jump out of the helicopter, or you can take the relevant example like buses. When you run out of the buses, moving bus, from a moving bus, if you move down, what happens is that since you have so much momentum, and you will also see all these things in inertia when we do laws of motion, so there you will realize that you are also moving. It's the bus which was moving and you were inside the bus. So when you came down on earth, when you came down on ground, it should happen that you should stay static, but it doesn't happen. We also tend to move because of inertia and whatever concept with the same velocity, because our body tend to be kept in that. So here also what happened, helicopter was rising with velocity of 2 meter per second. Now food packet has been dropped. Now obviously velocity of food packet will change, but initial velocity which we write as u, the magnitude of it will be 2 meter per second. Let's take the same sign convention. Upwards as positive, downwards as negative. You can reverse this also, you will get the answer differently, where your minus sign will signify something else, plus sign will signify something else. So packet is moving downwards. Packet is moving downwards, but do you think that packet will immediately just fall downwards? See, from a helicopter, if you throw a packet, first it will also move. It will occur like this. This is the helicopter. Inside is this is the food packet. What will happen? The helicopter is rising. See, it is slowly. This is how the food packet will be thrown. Like this will be the motion. Even if you throw something from moving thing, first anything for throwing it, it rises and then falls. So that's why we say the food packet's initial velocity will be pointing upwards, and we'll write it as positive. Acceleration will be acceleration due to gravity, that is minus 10 meter per second square, because it is acting downward, so we'll add the negative sign. After 2 seconds, no, so time duration is given as 2 seconds. We have to find what? Final velocity. A connecting equation. So Maha, can you give a connecting equation between all these three? You have to find out the velocity.
V is equal to u plus at.
Perfect. V is equal to u plus at. V is unknown, U is 2, A is minus 10 into 2. This becomes 2 minus 18, 2 minus 20. That's minus 18. So this is 2 minus 20, which is minus 18 meter per second. That's your answer. So when we all are getting, see, one thing also, like you both answered Aram and Maha as minus 18. So how do I know whether your direction is correct or not? That can only be correct when you, it's better when you're answering no. And I don't know which sign convention you have taken. It could have happened that Maha, you must have taken upwards as upwards as negative and downwards as positive, and your final velocity is coming negative. So different interpretations can be done. It's just better if you signify your sign convention. So when you're answering to me, you can either write it down. Like for example, if I was a student and I solved it and I was getting this answer, so I would write it to my teacher as 18 meter per second downwards. So whatever sign convention the teacher chooses or the student chooses, ultimately direction will be downwards. Yeah. Any doubts to anyone? Note this down as well. New students as well. Fatima, any doubt in here?
No.
Now, one more point that was left when we were discussing time of ascent and time of descent. So, as I told you that time of ascent is actually time of descent. But if we consider the resistive forces, air forces, the drag forces, so what happens in that case? Your time of ascent decreases and time of descent increases. Fine. This is the case if we consider acceleration due to gravity is occurring, all different forces that are occurring. So see, basically, this is when we consider air friction. All right. So do mention this point. It can come in your theory question. One last question that let's do, then we'll end the class. See, the question says that two balls are thrown simultaneously, vertically upwards with a speed of 20 meters per second, and B is thrown vertically downwards from a height of 40 meters with the same speed, that is 20 meters per second, along the same line of motion. You have to find out the point where the balls meet. It's like this is the tower, 40 meter is the height of it. Ball 2 has been thrown from here with the speed 20 meter per second. Ball first has been thrown upwards with a speed of 20 meter per second. At some point they will meet. Let's call this, let's take this distance as x. So if I take this distance as x, Aisha, can you tell me how much distance will be this?
Forty minus x.
Right. This becomes 40 minus x. Now, when balls are projected simultaneously, then time taken by balls to collide with each other remains the same. I'll write this point as well. Upwards, again, let's take it as positive. Downwards, let's take it as negative. And this is an important point, that when balls are projected simultaneously, obviously time will be the same. If both of you, let's say if two of you are reaching a point at a particular moment, then at that point time is the same, then only you're able to collide or meet. So in case of balls, when the balls are projected simultaneously, then time taken by balls to collide with each other is the same. Fine. Now, see, we have to write down two equations. For ball 1, we have to write down, and for ball 2, we have to write down. See, let's talk about ball first. Ball 1 first. So, Maha, can you tell me what should be the speed of the first ball? Everything is written in front of you, even the sign conventions.
Minus 20 meters per second.
First ball, where's the velocity going? Upwards, downwards?
Plus 20 meters per second.
Plus 20 meter per second. So velocity is plus 20 meter per second. See, acceleration due to gravity will be minus g, that is minus 10 meter per second square. Let's, okay, you've solved it, Aram. Yes, your
ma'am.
answer is right. Good, good. So by the same method you've solved it?
Yes, ma'am. Same.
Same, fine. Now, displacement for first ball is x, because our final point is this right now where the balls meet. So displacement is x, and obviously displacement is covered in the upwards direction. So we'll write displacement as plus x.
Ma'am,
Say, yes, Aisha.
G is 9.8, right?
Yes, G is 9.8. I have just taken it for the ease of calculation. We have to write it as 9.8. There will be a slight error in the answer. Like the exact answer should be what you are getting, error 15.1. But if you take it as 10, then your answer will be 15 something. So in the exams, obviously you cannot write it. Right now I just taken because it's looking 20 and everything. So 10 will be easier. But definitely, Aisha, in the examinations, you have to take it as 9.8 only. All right. So time is t. Now s is equal to ut plus half at square. Apply this equation for this ball. So s is equal to ut plus half at square. So this is x is equal to 20 into t minus 5t square, half at square. All right. So ball first is done. One equation I have now. Obviously, I cannot solve this equation further. Now ball 2. Initial velocity will be 20 meter per second, but ball 2 has been thrown downwards, so it will be negative. G, that's 9 - 9.8 only, but I'm taking it as minus 10 meter per second square for this question, just this question. Displacement will be this time 40 minus x, but with a negative sign. As you can see, ball 2 is covering this distance. It is covering the distance downwards. So 40 minus x will be having a negative sign, this much meters. T2 will be the same as the time. So ut plus half at square. Aram, you solved it using 9.8, no?
Yes, ma'am. 9.8.
That's why our answer was exact 15.1. I think most probably I'll get it as 14.9 or 15 exactly. Let's see. So S is equal to ut plus half at square. This is minus 40 plus x if I open it. Ut, so that's negative now, so minus 20t minus 5t square. So I have two equations with me. I have this first equation with me and I have this second equation with me. I just have to solve these two equations. So let me write it and solve. X is equal to 20t minus 5t square. This is minus 40 plus x is equal to 20 minus 20t minus 5t square. Let's add it because see, by adding most of the things will get this will get eliminated. Now if we subtract it, sorry, so this becomes, if we subtract it, this will become plus, this will become plus, and the sign changes, this becomes plus, this becomes minus. So this gets cancelled, you have 40t over here, and xx also gets cancelled, so you just have 40 over here. So time is what? Time is 1 second. Now we had to find out the displacement. Let's put it in the equation. X is equal to 20t equation. So x becomes 20 minus 5, that is 15 meters. The exact answer, obviously, you all should get the exact answer as 15.1 meters. But right now I'm taking it as 15 meters. Clear to all of you how to solve these kinds of questions? Motion under gravity, we have seen lots of questions today. Do one thing, note it down. So relative velocity is left from this lesson, and we'll see graphs, because without the help of graphs, you will not be able to solve any question further, because one time we at least have to do. So note this down. Just text me done in the chat box when all of you have written this portion. All right, Fatima has done. What about others? Ihram has already done it because she's got the answer. And Aisha and Maha, what about you both?
Ma'am, done.
All right, and Maha, what about you?